Hello, my name is Gerhard Adam, and in this module we will take a look at storing JCL for execution later or for invocation on an execute statement. In particular, what we're going to be looking at is storing JCL for use in a library. In particular, the idea of JCL being stored in a library is a term that we call a procedure, or a JCL procedure, or a proc. In particular, the libraries that contain this JCL are proc libs. And in particular, the purpose of this originally was that since most JCL was on cards, then clearly it made sense if we could remove a lot of the cards that were being carried around and store them on disk and execute it from there. Similarly, even though we are not using cards today, the role of a proc lib is to provide a library that can be controlled for security access. We can ensure then that we have proper audit controls, that production libraries, for example, are free from unnecessary modification or unauthorized modification. And so the idea of storing JCL for execution then is very much another part of being able to control what's going on in the data center, whether it be program changes, JCL changes, or anything else that would be associated with managing and running a production environment. So basically, when we execute a proc, what we are doing is we are specifying it on the execute statement. The libraries that contain the procs are searched. Once we locate a particular proc, it is expanded into the job stream, syntax checked, and then, of course, executed as we would normally expect from any job that we submit. A job can also invoke multiple procedures. As a result, we can have procs that we may have multiples of that we can invoke several times, or we may have different procs that we want to invoke, and it effectively becomes a shorthand way of being able to have stored JCL then that we could invoke in the job, as well as having inline JCL. So there's no restriction on our ability to use a proc or to have inline JCL coded, and we can use and mix and match them as we see fit within the job. Now, there's a few statements that occur here, and we're going to take the approach here of first taking a very simple look at it, and then looking at some of the issues that come up because of the fact that JCL is stored in a library. The proc statement is the statement that basically identifies that it is a proc. Now, generally, this statement is coded as the very first statement, but it doesn't actually have to be there. And we'll see examples as to why we normally use this and the role that it plays. In addition, we can have a append statement. Now, append statement is not required for any JCL that is stored in a library itself. There's a very specific use for it, which deals with in-stream JCL procs, and we'll take a look at what that particular requirement is. As we said, in-stream procs are where the proc itself is not actually defined in a library, but it acts as a definition in-stream in the JCL itself. This is a very specific usage. It is not something that you will normally run into as any kind of a production run or any way that people normally run JCL, but it is a useful way, for example, if you want to test a proc or if you wanted to make sure that everything is working the way you intended, is to run it first as an in-stream proc, make sure that everything's doing what you want, and then you can go ahead and move it into a library and be confident that it's going to work exactly the same way. And of course, the idea of a proc in a library, we also refer to that as a cataloged procedure. There's nothing special about that particular name or term. It's just a phrase that is used to describe a proc that is defined within a data set, and as a result, when that data set is searched, that proc can be located, expanded, and then run. So, the proc statement itself. As we said, this is normally going to be the very first statement within a cataloged procedure. However, it does not have to be there, and if it's not there, that doesn't affect the JCL in any way. However, we're going to see that when we have something in a library, we have to take into account what happens if we want to change some values. Now, certainly we could go in and we could edit the data set and change the JCL, and that would be the end of that. However, with a lot of these procs, since they are in fact production controlled libraries, it's not always possible to update the proc. And in some cases, a proc has sort of a generic use, and as a result, we may have hundreds of people that are using that proc for a variety of purposes, so making individual custom changes is simply not an acceptable way to go. So we have to have some flexibility that allows us to specify unique values or to make modifications to it that are unique to ourselves without actually modifying the actual JCL itself. And the proc statement can serve that purpose by providing a place for us to assign parameters or default values for different values that we can code within the proc itself. And we're going to see examples of that as we move through this particular discussion. So again, what we have is we have the beginning of the proc. We can have what are called symbolic parameters that we can assign defaults to on this proc statement. And of course, that is also going to be the basis then of what we use to identify the proc that we are going to be executing. The name in this particular case is a proc step name and does not represent what it is that we are executing. What we are executing is actually located by the member name within that particular partition dataset. But just as we saw with the step name on the execute statement, this would be a name that would reflect a particular proc that we are invoking. The pen statement, as we said, has no real purpose other than to mark the end of an in-stream procedure. And as a result, you will not see it used anywhere except in in-stream JCL. And in this particular case here, all we have on there is comments that can be added. It serves no other purpose other than to mark the end of a particular definition. So in this particular case then, what we can look at is we can see an example of what an in-stream proc looks like by examining the IEB gener that we've been looking at before. In this case, you'll notice that we have a proc statement at the beginning. We have the execute, sysprint, sysut1, and all the JCL to actually do the work. And then we have a pen statement. And following the pen statement, now we have the execute statement indicating we want to execute a proc called print ds. Now, in this particular case, the proc has been defined just prior to our executing it. And as a result, no proc lives will be searched because the definition is in line with the job itself. And this is what I meant about the fact that it's sort of an unusual situation, because what you're really doing is that you are creating a proc that you can test in this fashion, or you might even have multiple invocations of it. But the main point is that the proc itself is defined only within the constraints of this current job. It does not exist in a library anyplace. And that's where the pen statement comes in, is to mark the end of that particular definition, which was started with the proc statement. Here's an example of how that in-stream proc would be executed. And notice that when we look at the JCL, we can see statement 2 here indicates that this is the JCL that constitutes the proc that we are defining. Statement 3 is where we execute that proc that we have defined. And then you can see statements 4 through 9 represent the interpretation of that proc. And we can see that this is an in-stream proc because all of the slashes have been replaced with plus signs to indicate that this is the interpretation of a previously defined proc. Now, what's a little unusual here is that when we normally would run the JCL, then of course the JCL would be interpreted and executed. Except what we've done now is we've taken the JCL and said, instead of executing the JCL, we've defined this now as an entity called a procedure, and we are executing that procedure, which of course interprets that JCL now and allows it to be executed. So in the first instance, we're dealing with a definition of a logical entity called a proc, and then the plus symbols indicate the actual interpretation of that proc, and that represents the statements that we are executing. Now, in this particular case, there is no difference between the two. You don't see any substitutions, there's no symbolic values, there's nothing that indicates that there's a difference between our definition versus what it is that we finally executed. And so that may seem a little confusing, or you may even wonder, well, why would we do that? And in this particular case, of course, there is nothing that compels us to use this and suggests that it's a better way. But it's intended to illustrate the distinction between the JCL itself and when it's defined as an in-stream proc and how it can be invoked.